All right, guys, so this is the second part to section 7.5. Okay, so if you haven't watched the first part, please do watch the first part because this is actually a continuation of what we just did. Okay, so when we worked this out, we got x equals 3/2 and negative, this is a 3. Okay, but if you notice, when I look at my domain, guys, x minus 3 and x plus 3, okay, x cannot equal negative 3 here, because if we do, this would be 0, would be dividing by 0, which we cannot do. Okay, so that's an extraneous solution. So our only solution, our only real solution to this problem would be x equals 3/2. All right, so I highly encourage you to try to work this one out on your own. So go ahead, pause this, work it out, and then I will show you what I got for it. All right, so this is what you should have gotten after you did all the work, and there is a lot of work, I get it. You should have gotten x equals 2 and x equals negative 3/5. All right, let's look at example number 5. Okay, it says consider the function f of x equals 2 over x plus 3. Determine whether the inverse of x is a function. Okay, so remember, in order to do that, we're going to graph the function. So here, my asymptotes are x equals negative 3. Okay, and y equals 0. Okay, and it's positive, so I get something like this and this. Okay, this is my graph of 2 over x plus 3. Okay, now remember the horizontal line test. Okay, if this passes the horizontal line test, then the inverse of this is a function. Okay, now the horizontal line test says that if I can draw any horizontal line in this graph, anyone whatsoever, okay, all the way through, if there is any horizontal line I can draw where it intersects the graph of this more than one time, then it fails the horizontal line test. Okay, so as you notice, there is no horizontal line I can draw that would cross this graph more than once. Okay, therefore, I could say yes, inverse is a function. Okay, now to find that function, this is the same thing, guys. I'm going to change, think of this as y equals 2 over x plus 3. Okay, to find the inverse, I'm going to change the x and y, so x equals 2 over y plus 3, and then I'm going to solve for y. Okay, so I have a fraction. Anytime I have a fraction I want to get rid of it, I'm going to multiply by the denominator, and I'm going to multiply both sides by the denominator. Those go away, so I'm left with x times y plus 3 equals 2. Okay, so I can divide both sides by x. So I'm left y plus 3 equals 2 over x. And then to get y by itself, subtract 3 from both sides. So I would get y equals 2 over x minus 3, and that's the equation of my inverse. All right, let's look at example 5b. Okay, so here my f of x is 1 over x squared minus 7. We haven't done anything with this, so I don't expect you to know how to graph this without like plotting points or putting in your calculator or whatever. I can tell you when I do, it goes like this. Woo! Sorry, this is really hard to sketch on this tablet. Okay, I have an asymptote at minus 7, so it does this number. And then an asymptote at x equals 0, so it kind of rides the 0 all the way up. And then it does the same thing on this side too. And then it rides this all the way up. Okay, so that's what the graph of y equals x squared minus 7 looks like. All right, so notice if I draw a horizontal line here, I would cross that graph at 2 points. Okay, so immediately it fails horizontal line test. And therefore I can say, without knowing what the inverse is not a function. Okay, so Now I want to find the inverse. So to do that, okay, I'm going to flip my x and y, so x equals 1 over y squared minus 7. Okay, so I'm going to add 7 to both sides. I get x plus 7 equals 1 over y squared. Okay, so multiply by the denominator on both sides. So those go away. And I have y squared times x plus 7 equals 1. Okay, don't undo the, don't distribute this through, because we're just going to turn around and divide by x plus 7. Okay, so I am left with y squared equals 1 over x plus 7. Okay, now I want to get y by itself, so I square root both. So y equals the square root of 1 over x plus 7, which is the square root of 1 over square root of 7. Oh, x plus 7, sorry. Okay, now I need to rationalize the denominators. So multiply both sides by x squared of x plus 7 over square root of x plus 7. I'm left with y equals square root of x plus 7 over x plus 7. Okay, and this is plus or minus, right? When I take the square root, it's plus or minus. Okay, so this would be my final answer. And this is just a graph. This is just an equation, so I don't have to write that x cannot equal to negative 7. All right, let's look at example 6 now. Okay, so example 6 says in section 7.2, example 5, you wrote a function. Okay, here's my function right here, which represented the average cost of making M models of a 3D printer. How many models must be printed for the average cost per model to fall to $90? Okay, so we're going to solve this two ways. We're going to solve it by using what we know. Okay, so if we want the average cost, which is what C represents, to be $90, all we'd do is plug in 90 for C plus 1,000 over M. Okay, so when I multiply on both sides by M, I get 90M equals 50M plus 1,000 minus 50M. 40M equals 1,000 divided by 40. I get M equals 25. Okay, that's one way to do it. Okay, now if I want to do it by finding the inverse, all I'm going to do is solve this function for M. I'm going to rewrite it to where it says M equals whatever. Okay, so the first thing I'm going to do is multiply M on both sides. So I'm left with CM equals 50M plus 1,000. Okay, I want the M's on one side, so I'm going to subtract 50M. So I'm left with CM minus 50M equals 1,000. Okay, now I'm going to factor out an M. Okay, then to get M by itself, I can divide both sides by C minus 50. Okay, so I'm left with M equals 1,000 over C minus 50. Okay, now I want to find how much for the average cost to be 90, so my C is 90, so M equals 1,000 over 90 minus 50, so 1,000 divided by 40. And I would get M equals 25. Okay, so you would get the same answer as over